Hi, here I am doing the extra credit lab activity online. You could see that, oh, where is the Moodle? On the Moodle, it says that for the extra credit, you can do Module 16 and Module 17 in Unit 4. So, it is necessary to use Firefox to do this virtual lab. And in Firefox, you can see that there is a Unit 4, and Module 16 and Module 17 are here. So when you open Module 16, you can just keep on clicking on the links, and you will arrive at this page. We are working on this chemical equation. So let me explain to you something about that chemical equation before you start doing this work. When you mix in some container some sodium chloride solution with some silver nitrate, what happens? You can see from this chemical equation that you get the double replacement reaction, and one of the products is aqueous, so you will not see it. It's colorless and clear. The other product is solid. You will see it. The silver chloride solid becomes some flakes, white and gray flakes, and they sink to the bottom of the container. What does this mean? That means inside this container, at the end, in your products, you will have Na plus ions, and you will have NO3 minus ions, but you will not have any Ag plus ions. You will not have Cl minus ions. Why not? Do you understand? It's because AgCl will form the solid. You will have AgCl solid at the bottom of the container. So, if you understand that, then you can understand this entire extra credit assignment. All right, let me show you how to use the tool, the virtual lab. It needs Java, and this is why you must try the lab in Firefox instead of Chrome. Number 1, the solution labeled 1 gram of NaCl. I must verify that the Na plus and the Cl minus add up to 1.00 grams. So, 1 gram NaCl, there it is. You can see that if I click on the container, I see this information. I see that there is no gas, there is no solid, but there are these aqueous things. These are their concentrations in molarity. However, if I want grams, I can just click on molarity and I'll get grams. Did you see that? Molarity, grams, moles, I can get any information I want here. Right now I want grams. Now notice these numbers. They have E's by them. What do those mean? Let me show you. (1.016 E minus 8). What does that mean? Well, that means 1.016 times 10 to the minus 8 grams. E minus 8 just means 10 to the minus 8. Okay? What does that mean? I think you know. It means this is a number that this number means. In this virtual lab, or in all of the labs that you do of you using this software, a number like this is just 0. Any number with e to the minus 8, e minus 7, e minus 6, e minus 5, or even e minus 4. Any number with this at the end means 0. Okay? And the reason for that is they are so close to 0 that we wouldn't be able to measure them in this lab. Okay? I mean, obviously the software can measure them, but we wouldn't be able to notice the change if we were to add them or subtract them from other measurements. Okay? what about this number? 3.934 e minus 1. What does it mean? It means 3.934 times 10 to the minus 1 grams. And what does that mean? It means 0.3934 grams. So in number 1a, you must add this number and verify that they add to 1.00 grams. Your answer for number 1a will be either yes or no. You will do the same for silver nitrate. Take the 1 gram of silver nitrate. There is a little problem with that silver nitrate though. You're going to have to get some water, put it on top of the silver nitrate, and then at the bottom of your software tool, add 100 grams, 100.0. You can just add 100 grams. The software does not know how to use significant figures. So even if you just said 100, it would do the same thing. Pour that water in there, and then move that water away. Click on the silver nitrate flask, and there is the grams of nitrate and the grams of silver. 0 of this and 0 of that. 0 H plus and 0 OH minus. Okay? You must add silver and nitrate together to verify that they add to 1.00 grams and say yes or no for number 1b. What about 1c? You will take the 1 gram of solid silver nitrate. Now that is this here, solid silver nitrate. There is no 1 gram in front of it, you see? It is a bottle with a black top on it. So you'll take the 1 gram of solid silver nitrate and add that to the 1.00 grams of sodium chloride. Write down the mass of everything in solution and the mass of the solid. Let me show you how to find that. Okay, we take the sodium chloride and we take the silver nitrate, and you will start adding here by putting a number right there. Okay, now I don't want to do this lab for you, so instead of using 1 gram of sodium chloride, I'm going to use some other amount. This portion you do not do. I'm only doing this to make my work different from your work. Okay. You can see I'm adding 4.55 grams here so that the total grams of sodium chloride will be 5.55. Okay, so this is now 5.55, so I'm going to rename this. Okay, you do not do that. I am only doing this to make my work different from yours, so that when you do your work, it will be the work that you have done, not the work that I have done. Okay, so I'm going to add this for number 1C. I'm going to add some number of grams here. I'll add 1 gram here. I pour that in. Notice that when I add 1 gram, I click on the flask again, I could see that there's 0 grams of silver. Why? It is because, remember, any silver nitrate that I add to sodium chloride gets removed because it makes silver chloride solid. Let me see that silver chloride solid. If I click on solid, I can see all the solids. I made this solid here. I made 0.8 grams of this solid. Okay? Go back to the aqueous. You can see I have 0.3650 grams of NO3 minus ions in here. Watch me add some more. Oops. What if I add 2 more grams? Click on the flask. I still have 0 grams of silver ions in here, and now I have 2.5 grams of silver chloride in here. Okay? So this is what you need to do. You need to add 1 gram of silver nitrate to your 1 gram of sodium chloride, you know, that thing. And then you need to write down how many grams of silver chloride you get from there and how many grams of every dissolved thing you get. And remember, that means 0, that means 0, and that means 0. Number 2. The solution labeled solution 1 contains 2 grams of sodium chloride. How many grams of silver nitrate must be added? Okay, for 2A, you do not use the software. you must do the calculation. I will use 5.55 grams of sodium chloride. You will use 2.00 grams of sodium chloride. Let us do the calculation now. We want to know grams of silver nitrate. Here is the chemical equation. Here's my notebook. So, 5.55 grams of sodium chloride. Remember, I'm doing 5.55. You're doing 2.00, okay? That's what you're doing. 5.55 grams of sodium chloride. How much silver nitrate do I need? Well, I'm going to use the chemical equation for this. The chemical equation is in moles, not grams. So I will now change this to moles. In 1 mole of sodium chloride, there are about 58 point something grams. How do I know? Oops, sorry. I must use the periodic table. 23.0 plus 35.5 is 58.5. Okay, so this is about 58.5 grams of sodium chloride. These cancel. And I want grams of silver nitrate. So I know that there are 1 mole of sodium chloride right there. And you see there's 1. There's no number there, so that means 1. 1 mole of silver nitrate. All right. And now I know that in 1 mole of silver nitrate, there are 169.87 grams of silver nitrate. Okay. So now I have grams of silver nitrate as the only unit that's not crossed out here. You see what I mean? So I can do the calculation now. There we are. So I have 16.1 grams of silver nitrate. If you write 16.1 grams of silver nitrate for number 2, your answer will be wrong and you will not get any points. Why? Because I'm doing this. You are doing something else. I'm doing 5.55 grams. You, how many grams are you doing? That's right, you're doing 2 grams, okay? By the way, how do I know that 169.87 grams of silver nitrate are in 1 mole of silver nitrate? I know by using the periodic table. But you know, if you don't want to use the periodic table, you can just use Mrs. Google. Like this, see? Boom. Answer. Is that neat? Did you know that? I bet you didn't know that, huh? Okay. So that is my answer for number 2. Your answer will be different. And then in 2B, you must use the virtual lab to verify that. Okay? Let me do that. Let me do my version of this. So I'm going to get my solution number 1. Okay, get rid of these. So solution number 1 contains 2 grams of sodium chloride. However, I'm going to use something else. You do not have to do this part. I'm just doing this to make my work different from your work. So this is Glenn's solution number 1. Now I will get my silver nitrate and I will add my, what was it again? 16.1 grams. I will add my 16.1 grams and I could see that chloride is almost 0. This is something times 10 to the minus 3. I'm not sure if this can be considered as 0 or not. It says somewhere in the lab. Let me see. I forgot where it said that, but this should be 0 because I should have used all of the chloride ions. So I think this may be equivalent to 0. Well, let's see. .766 times 10 to the minus 3 equals 0.006766. Is this equivalent to 0 for us? No, I don't think so. No, because if I added this number to some number here, such as this number, this is also, this 3 right here, this is also 10 to the minus 3. So I do not think that is equivalent to 0. Okay, let me add some more. What happens if I add 0.01 grams more? I still don't get 0. Is there something wrong with my calculation? It's another 0.01 grams. Another. Ah, there we are. Okay. So it really should have been 16.13 grams. So this software wants you to use 4 significant figures if you want the right answer. So what does that mean? That means on the calculator, I don't have 16.13. Maybe I need to get this number with some better significant figures. Molar mass of NaCl. 58.44. Okay, that will make a difference. So let's see. 58.44 grams. So 5.55 divided by 58.44 times 169.87. Ah, there it is. That's what the software wanted. Okay, so this software needs for you to have the answer in 4 significant figures. Okay, the software does not know how to count significant figures, but it does. It just knows that whatever answer you get, it needs to be in 4 significant figures. Otherwise, you will not be able to get the correct result in the lab. All right. Here, let me show you one more time. I will get solution 1 here. I'll add my, oops, oh, that was the wrong thing to do. Sorry about that. I'll get solution 1 here. I'll add my sodium chloride. Okay. And I want to make this into Glen's solution 1, which is 5 grams of sodium chloride. Okay, and then the silver nitrate I'll add here. If I add 16.13 grams by doing 4 significant figures for my calculation, then I get a very nice 0 chloride ions. Okay, that and E minus 4 and less, that is equal to 0. And then I'm going to be answering the question of number 2A, I mean 2B. Oh, okay, I see. The question just requires the sodium, the silver and the chloride to be less than 0.01 grams. So even if you only use 3 significant figures, you just need to have E minus 3. It doesn't have to be E minus 4. So sorry about that. You can have just 3 significant figures. That is okay. So your answer for question 2B will be yes or no. Okay. Sorry about that confusion. So number 3. If you have questions about this, please ask me. You can send me email or you could even call me. Thank you. Number 3, if the solution number 2 contains 3 grams. All right, so this is very much the same thing. In number 3, you will be using the silver nitrate. solution 2 right here, silver nitrate. And you will be calculating how much NaCl you need. You will be calculating how many grams of AgCl you can form from this 3 grams of AgNO3. So you will use the chemical equation, and if you have 3 grams of that AgNO3, then how many grams of that AgCl can you form? Okay, you will do that calculation. I can do a similar calculation. I don't think you need me to do this, but I can do it. You know, it goes like this. It's going to be just the same thing. And you're going to get the answer in AgCl. It's going to just be that thing. It's just going to be AgNO3 and AgCl instead of number 2, which was NaCl and AgNO3. Okay? And then in 3b, the virtual lab, you are going to check your work. So you'll take solution 2. Let me clean up here. You'll take solution 2, and you will add the amount of, you'll add a whole bunch of NaCl. Okay, so let me make this a little different than yours so that you can do your own work and not my work. All right, AgNO3. Okay, so here is my solution 2, and you just have to add a very large amount of NaCl. I could add 100 grams. Okay, so I am sure that you can see there's some gray stuff here. Isn't that funny? I am sure that after adding 100 grams of NaCl to my 5.55 grams of AgNO3, and for you it's going to be 3.00 grams of AgNO3, but after adding 100 grams of NaCl, I have completed whatever reaction was going to happen. So now I could see that the solid AgCl is this number. So this number needs to match, that number right there, that number needs to match the number that I calculated here. This number right here needs to match this number right here. Okay? So you figure that out and let me know if you have questions. And that is it for module 16. I'll make another video for module 17. Thank you.